Okay, we are now recording, and we now have slideshow on. Let me hit these as quickly as I can. I think I asked this before, none of you are graduating this term, right? So these first three do not, or three of them don't pertain to you. If any of you are interested in the math team, they meet this afternoon at 3 on the Birmingham campus. Of course, I don't think any of you make that. Or Friday at noon. But they won't meet this Friday because we have professional meetings in Jasper. Okay? Our homecoming week is coming to a close tonight with the game day Monday. The festivities start at 4 o'clock when we have the homecoming parade and the pep rally. The parade starts at the Birmingham East Campus at the gazebo near A.G. Gaston building, right? And then they'll proceed down Wilson Road onto the Birmingham West Campus to the gym, which is the Arthur Shores Fine Arts building, and in there. No, it's Courtney, yeah. All right. Anyone else coming since I called roll? Okay, so the parade will end at the gymnasium, which is Arthur Shores Fine Arts building. Is that where the pep rally will be, or will it be at both places? At the gym? It'll be at the gym. Okay. And that will probably be through by 5-ish or so, but the game starts at 5:30. That's a homecoming game, Lawson State versus Gadsden State. The women play at 5:30 and the men at 7:30. Both in Arthur Shores Fine Arts building, which is our gym on the Birmingham West Campus. I think I told you last time about the various tutoring. I thought I turned that on. Okay, I guess I didn't hit the button well. Various tutoring opportunities available on both campuses. If you need to see those, I've got them here. Or any questions about any of them, I have them here. All right, now, they are whamming us with meetings, okay? Wednesday, they've called a meeting for 2 to 4. I've told them I can't go at 2. I can't go before 3:15. And they said, okay. So as soon as class is over on Wednesday, I'm booking it over to Ethel Hall Auditorium where we have a meeting. I'll go in late. Okay? That's Wednesday. Then Thursday, they have another meeting from 2 to 5. Now that one I can go to because I don't have any classes Thursday afternoon. But 2 to 5, 3 hours out of my afternoon, I do not need that, but that's when they called it for. And this will be Thursday afternoon. Again, the good news is it's on this campus in the President's Conference Room in Ethel Hall, right across the parking lot. And then this last thing was none of you are graduating this term, so we'll skip that too. But if you know of anyone who's graduating, okay, let me tell you about the first two. Presidential scholarships from UAB and University of Alabama at Tuscaloosa are available, but the first bit of the data have to be in by 5 today, okay, and then the whole application has to be in by Thursday on the 1st. So if you know of anyone graduating, let them know that so they can get moving on it today. Also, if you know they're graduating, there are 3 meetings next week. One Monday evening on the Birmingham West Campus, ACAT building. One here, I think 3:30 in the afternoon or something like that. 1:30 in the afternoon, Ethel Hall Auditorium, and then Wednesday, 1:30 in the afternoon in the ACAT building on Birmingham West Campus. Okay. I think I got everybody marked here. Any questions on anything we've done so far? All right, in section 11.3, we were talking about the slope of a line. We, of course, all remember everything from there, right? Weekend working on those homework exercises, fresh on your mind. Good, good. Okay. Now, the third objective in this section is to use the slope to determine whether two lines are parallel, perpendicular, or neither. Okay? And here are the general rules for it. If you think about it. Two lines are parallel, whatever they happen to be. What is true about them? They have the same slope. Because if they got the same slope, they're never going to intersect. Unless they're one on top of each other to begin with. Okay? Then they intersect everywhere. So two lines with the same slope are said to be parallel. Or two parallel lines have to have the same slope. Now, let's think about perpendicular lines. What does that mean? Perpendicular lines. Second? They intersect. They intersect for sure. But any two lines that are not parallel are going to intersect. How do they intersect? Perpendicular. Okay, at 90 degrees. Okay? Now let's just imagine that's 90 degrees. This is going to be line 1, this will be line 2, okay? What can you tell me about the slope of line 1 here? Positive. Slope of line 2? Negative. There's one thing to note about two perpendicular lines. One's going to have a positive slope, the other's going to be a negative slope. With one exception. Huh?
Zero.
Zero slope for this one, and
Zero.
Undefined slope here. The denominator is 0. Delta x, the change of x is 0 there. Okay? So except for horizontal and vertical lines, which are perpendicular, one of them's a 0 slope, the other is undefined slope. All other perpendicular lines, one's positive and one negative. Okay, so let's go back to this. Again, this is the line 1, this is line 2. What can you tell me about the relative slopes? We already know the signs. What would you say about this slope? Large, small? Very steep slope. And that's negative, right? This one would be pretty shallow slope, positive, right?
Yeah.
Yeah. Okay. So, and if this one decreases magnitude, and that one increases, you see large positive slope, small negative slope. Okay? So, what does that mean? Well, opposite signs for sure, but two lines whose slopes have a product of -1. Negative because one's positive, one's negative. It's got to be a product that's negative. The other thing is this is quite large, this is quite small. This is quite large, that one's quite small. So the product is going to be 1, actually a -1. So two lines whose slopes have a product of -1 have to be perpendicular, or two lines who have a product whose slopes are, the product of whose slopes are -1, they're going to be perpendicular. All right. So here's example 6. Okay? What we're asked to do is to decide whether each pair of lines is parallel, perpendicular, or what's the other option? Neither. So what will tell us whether they're parallel? No, that's perpendicular.
Oh, parallel.
Parallel.
Same slope.
Same slope. Perpendicular. It's not enough to be positive and negative. What must it also be? The product of the slopes is -1. Exactly. If it's anything other than that, if they're the same slope, parallel. Product of the slopes, -1, perpendicular. If the product of the slopes is, if they're not the same slope, and the positive and the product of the slopes are positive, neither. Okay? Any number other than -1, neither. Okay? If there's only very certain prescriptions for parallel or perpendicular. Most any old two lines you throw out there usually are going to wind up neither. Only very rarely will they be parallel or perpendicular. So how in the world can we tell, just looking at this equation and that equation, whether or not these are parallel, perpendicular, or neither? And there's evidence. What do you think we would do first? Okay, get it in slope-intercept form. In other words, solve for y. Let me get my pen activated properly. Okay, we're going to solve for y, and what does that give us for the first one? Okay, say again. Oh, you're going to subtract x from both sides. Okay, that's permitted. This will add the zeros. That negative 2y equals negative x plus 4. Perfect. Now what? Divide everything on both sides by negative 2. I can't write. Okay. And what does that give us? Y is equal to 1/2 x minus 2. And for what we're doing now, we couldn't care less about the minus 2. Other times, yeah, it's going to be important. Right now, if we're only determining parallel, perpendicular, or neither, what are we looking at? Slope, the 1/2. Okay, so the slope for this line is 1/2. Okay, what do we do with the next one? Second?
Same thing. Minus 6x.
Subtract 6x from both sides, and that gives us 3y negative 6x plus 9. Now what? Divide everything on both sides by 3. Okay, that will give us y is equal to negative 2x plus 3. Okay, what can you tell me about those two lines?
They're
Perpendicular. They certainly are not parallel because this slope is not the same as that slope. However, the product of 1/2 and negative 2 is negative 1. So those are perpendicular. So these two are perpendicular. Good deal. Okay? Any questions on that? You see here the slope of the second one is negative 2. Okay, now, do I always multiply those two slopes together to see if it's negative 1? Generally, I don't. I look at the 2. On this one, m is equal to negative 2. And I ask myself, are these negative reciprocals of each other? To me, that's far easier than multiply. That's a 2. The reciprocal of 2, this is a 1/2. The reciprocal of 1/2 is 2. Only that's negative. Done. They are perpendicular. All right. Let's see what they do with it. Any questions for our race? Make sense? Okay. Find the slope of each line by first solving each equation for y, which gets it in slope-intercept form. So they write down the equation again. What a good move. Then they subtract x from both sides. Again, another good move. They're copying what you did. That gives us negative 2y is equal to minus x plus 4. To put it in slope-intercept form, it's always x, then the constant, so that's why we do it that way. Divide everything on both sides by negative 2. That gives us a y on the left is equal to 1/2 x minus 2. For right now, we couldn't care less about the minus 2. All we're interested in is the slope of 1/2. Okay? Do the same thing. Slope is positive 1/2. Then we do the second equation, same thing. Subtract 6x from both sides. That gives us 3x is equal to negative 6x plus 9. Then when we divide both sides by 3, everything on both sides by 3, you get y is equal to negative 2x plus 3. Again, the plus 3 isn't of any consequence to us. What's important is the slope. That slope is what? Negative 2. And 1/2 and -2 are negative reciprocals of each other. Therefore, those two lines are perpendicular. Good deal. Any questions? Just as y'all did it. Okay? Now, here is 6B. Well, do you want to do 6A from the book because it's a different problem, or do you want to go and do...
Hit it one more time with the graph.
What's that?
Hit it one more time.
Oh, I see. Okay. I thought this was the B part. Sorry. Because the slopes are not equal, the lines can't be parallel. To see that the lines are perpendicular, find the product of the slopes. Actually, I just look and see if they're negative reciprocals of each other, but the product of the slopes is also -1. That means they are perpendicular. Slopes are -1. The product is. Here is the first line of the fence. That's the one with slope of 1/2. Now here we do use that y-intercept. Go back to the problem. Okay, the y-intercept was -2 and the slope of 1/2. So how I would graph this is start with that. Y-intercept is -2. That's where it intersects the y-axis right there. It's -2. Yes, and then your slope is positive 1/2, up 1 for every 2 to the right, up 1 for every 2 to the right, up 1 for every 2 to the right, or that same 1/2 can be a -1 over -2. That's also a slope of 1/2. And there we have that intersection, -1 over -4. I mean, for one down and one to the left, there's another, and then another one out here. So sure enough, there is the line that is represented by the first equation. Okay? For the second equation, just to remind ourselves, it was, I've got my itchy nose, 2x plus 3. Okay, I'll take your word for it. So we'll start there with a plus 3, right? And the slope was? -2. So how do we plot points there? Down 2, right 1, down 2, right 1. Bingo, they cross right there. Down 2, right 1, down 2, right 1. Or you could have gone up 2, left 1. That also is a -2 slope. It would be a positive 2 over -1. That's also -2, and then you can draw your supposedly straight line in between. Now, Greg Joyce here. Here's what I do not recommend you do. Just graph the function and look at it and say, yeah, they look perpendicular to me. Okay? Because, especially if you draw as ugly a lines as I do, okay, or they look pretty close to being perpendicular, but I can't look at any two lines and say, yeah, those are perfect. No, that's, yeah. They can be close, but no cigar. They have to be exactly have a product of -1. -0.967, I can't look at that and tell a difference between -1. Okay? It's just too close, or -1.03. They may be very, very close, but those aren't perpendicular then. So this is the way to tell perpendicular, not by looking at the graph. They look like they could be, but don't trust looks. Okay? Looks are deceitful. No, I didn't say that, did I? Okay. All right. So there is the rest of 6A. There's that line. See, they almost draw as pretty as I do. Okay? Now, again, even looking at their drawing, I can't tell for sure if those are perpendicular. The slopes are what tell me they're perpendicular. Don't trust the apparent perpendicularity of it. Make sure you understand for sure. Okay, now do you want to do 6A from the book and then come back and do 6B from the slide? Which is your preference? Any preference? Okay. Let's go back and do 6A. Whoops. Oops, that one. Okay. 6a from the text, here are our two equations. Okay? X plus 2y is equal to 7, and negative 2x plus y is equal to 3. Okay? What would you do with the first equation there? I'm sorry? Subtract x, that's correct, because what we're trying to do is solve for y. So let's subtract x from both sides, and what does that give us? 2y is equal to negative x plus 7. Next, divide everything on both sides by 2. And what does that give us? Y is equal to negative 1/2 x plus 7 over 2. And that's, I'm probably not going to start off this one by graphing the y-intercept, okay, when I get to the graphing portion, because that's an awkward little point to graph, okay? So I'll find something else to do there. But what we're interested in is the slope. Say again?
Would you convert it to 3 1/2?
You could, but it's still hard to graph that way. Yeah, it's the same thing. Yeah, 3.5 would work just as well. It's just as hard. Okay. The key here, the slope, is negative 1/2. That's what we're interested in when we're determining parallel, perpendicular, or neither. Okay, how about the second equation? Again, solve for y. So what do we do first? Not yet. Add 2x to both sides. And that wipes this out here, and that gives us y is equal to 2x plus 3. That one will be easier to plot because its y-intercept is a whole number, but who cares about that for right now? All we're interested in, are they parallel, are they perpendicular, are they neither? What would you say? Help me. Say again? Why neither? Okay. M here is equal to what?
Oh, never mind. It's
2. And those are negative reciprocals of each other. That's what I look at. Yeah, you can multiply them and see if they're negative 1, but look at them and see if they're negative reciprocals of each other. Indeed, they are. Okay? And I think they proceeded to graph these as well. So I will do so. Okay? That first one's a pain in the neck, but actually, the better way to graph that first one, to graph the first one is to do your intercept method. That'll work at least one intercept anyway. Which intercept is going to be easy to do? The x-intercept. So y equals 0, and what do you have? X equals 7. Okay? So when x is equal to 7, let's see if we can tick off these points. 1, 2, 3, 4, 5, 6, 7. There's x equals 7. Here we have a negative 1, 2, 3, 4, 5. Okay? A positive 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7. Okay. So 0, 7 is, 7, 0 is your x-intercept. Okay? And then, since we know the slope is negative 1/2, where do we go from there? Where do we go from there? Down 1, right 2. So somewhere over there. Or, I've got more room here if I go up 1, left 2. 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 Something about, whoa, got off there, didn't I? Up 1, left 2 is something like that. Up 1, left 2 is something else. Yeah, pretty ugly line, right? Something like that. It's supposed to be straight. Forgive me, I don't know what I'm doing. Okay. Now, for the second equation, that's set up perfectly for your slope-intercept. Okay? What's your slope? We already said it was 2. What's your intercept? 0, 3. Okay, we always give a point as an ordered pair. It's 0, 3, because you set x equals 0, you get y equals 3. So that's right here. Okay, awfully close to that line. And where do we go from there? Up to right 1. Okay, something about like that. Up to right 1, about like that. Up to right 1, somewhere up there. Or down to left 1. Negative 2 over negative 1 also is a slope of 2. Down to left 1. Down to left 1. I don't know where we left them, but we left them somewhere. Okay, down to left 1. Down to left 1, somewhere about in here. And there we have, don't draw straight lines. That's supposed to be perpendicular, okay? I don't draw too well, so it's not going to look too good. Now, that point of intersection would be a real pain in the neck to do, but we're not doing that yet. All we're interested in is where whether they're parallel, perpendicular, or neither. That one's perpendicular, because the product of their slopes are negative 1, or the way I like to do it, the slopes are negative reciprocals of each other. Okay. So let's proceed, and you got that in your text too. Let's proceed to the B part. Any questions before we move on? All right, here's the B. Again, determine whether each pair of lines is parallel, perpendicular, or neither. Okay? Here's B. The first equation, 8x minus 2y is equal to 4. What do we do first? Say that one more time. Okay, we want to solve for y, so we're going to subtract 8x from both sides. And what does that give us? Negative 2y is equal to negative 8x plus 4. And now what? Divide everything on both sides by negative 2. And what does that give us? Minus 2. Nice, handy, concise little formula there. What are we interested in? The slope. And what is the slope? M is equal to 4. All right, let's proceed with the other one. Okay, solve for y. You subtract 5x from both sides. What does that give you? Minus 3. Okay, and what can you tell me now? Anybody? Second? It's a neither, because the slope of the second line is negative 5. Negative 5 and 4, sure, they're opposite signs, but they're certainly not reciprocals of each other. So therefore, no way. That's a good old neither. Okay? And, yeah. So, everybody see that? Agree, disagree, uncertain? All right, what we're going to do now, by the way, both of these are going to be pretty easy to plot lines because they're set up perfectly slope-intercept form. Okay, no fractions. So let's clear that out of the way. But y'all got it written down, right? Okay. And let's see what happens. Find the slope of each line by first solving for y. So that's what we did first. What's the first step here? Subtract 8x, solve for y, so you isolate the y, minus 8x on both sides, and that gives you minus 2y is equal to minus 8x plus 4, and then we what? Divide by negative 2, everything on both sides. That gives us y is equal to negative divided by negative is positive 4x minus 2. Slope of 4. Do the same thing to the other side, even easier. Subtract 5x from both sides, and that gives you y is equal to negative 5x minus 3. Slope there is minus 5. They certainly are opposite sign, but nowhere close to negative 1 product. Okay? Not reciprocals of each other, certainly not opposite reciprocals of each other. So hang it up, Jack. That's a neither. Do they graph it? Okay. The slopes are not equal. The lines are not parallel. Find the product of the slope. Negative 20 is real close, but not quite negative 1. No, it's not even close. Okay? So the lines are not perpendicular because the product is nowhere close to negative 1. Lines are neither parallel nor perpendicular. Okay, that first one was pretty easy to plot. What was it again? 4x minus 2. Okay, the minus 2, there's your y-intercept. Up 1, 2, 3, 4 for every one you go over. 1, 2, 3, 4 for every one over. Yep, that's heading right. Or down 1, 2, 3, 4 for every one to the left. I was saying over, I should be saying to the right. So there's the slope of that one. There's a graph of that one. Now we do the other one. Its y-intercept was minus 3. Okay, there's the minus 3, and minus 5x, the minus 1, 2, 3, 4, 5. I can't tell, but it looks right. But if we go the other way, up 5, 1, 2, 3, 4, 5, and left 1, sure enough, that's on the money. 1, 2, 3, 4, 5, and 1 down. That looks like it'd be on the money too. So, yep. There are the two lines. They intersect, meaning they can't be parallel to each other, but they certainly don't intersect at right angles. No matter how lousy you draw, you can't even imagine those are right angles. Okay, they're not. Very acute this way and very obtuse that way. So neither parallel nor perpendicular. What's that? What's the what? It's just the product of their slopes. The slope of this one is a plus 4. The slope of this one is a minus 5. The product is a negative 20. If that product had been negative 1, they're perpendicular. If the product was, if they're not the same slope and the product is anything other than negative 1, you know, they're neither. That just shows it's a neither. What's that? Negative 1 just tells you that, okay, it's probably before you came in. Let's just imagine these two are perpendicular lines. They look approximate anyway, right? Okay, tell me something about this slope here. Down. Okay, from my perspective it's going up, but from yours it should be down. So it's a negative slope. This one would be a positive slope, right? This would be a large number or a small number? Yeah, okay, negative, but a large negative number or a small negative number? Pretty large, because that's steeply down. But this one is?
Very shallow.
Very shallow, exactly. So that would be a small number positive, a large number negative. The product of those two, if they're negative 1. In other words, this is a fraction less than 1. This is a large number greater than 1. So if the products are exactly negative 1, that means they are perpendicular. Or the way I like to say it, if they're negative reciprocals of each other. So what would have had to been the slope of the second line for that to be perpendicular? Negative 1/4. Negative reciprocal. What would have had to been the slope of this line over here for that to be perpendicular? Second? No. Not negative. positive what? But not 5. 1/5, exactly. Opposite sign, reciprocal. That's what the two slopes have to do. And those are obviously not, okay? Product being negative 20, yeah, that tells you they're not, but just looking at them, you can tell they're not negative reciprocals of each other. So the two things, the product, the two slopes have to be opposite signs and reciprocals of each other, negative reciprocals, okay? All right, now I think we're ready to do, oh, there's a C here. Oh, yeah, okay. Did I do the B from the book? I don't think I did I? Y'all need to see it? I'll be glad to do it. All right. B from the book is 3x minus y is equal to 4, and 6x minus 2y is equal to negative 12. Okay? What do we do if all we're interested is whether they're parallel, perpendicular, or neither? What do we do? I'm sorry?
Slope-intercept form.
Okay, get them in slope-intercept form. What's the procedure to do that?
Minus 3x.
Okay, isolate the y. That means we subtract 3x from both sides. Okay, and what does that give us? Negative y is equal to? Negative 3x plus 4. Okay, next, divide or multiply by negative 1. So I'm going to negate that sign, and negate the last sign. I'm doing it the lazy way. Okay, so there is your thing. I either multiplied or divided both sides by minus 1. That means you change every one of the signs. That's all you're doing. Okay, next one. Say again? Okay, subtract 6x from both sides. And then what? Negative 2y is equal to negative 6x minus 12. Now what? Divide everything on both sides by negative 2, negative 2, negative 2. And what does that give us? Y is equal to? I can't hear. 3x plus 6. I can't hear well. All right. Now, what can you tell me about those two lines?
They're parallel.
They are parallel lines. Okay? What gives that away?
Same slope.
They have exactly the same slopes. So they've got to be parallel. Oh, maybe not, though. What else can you tell from this one? This one you do pay attention. Once they have the same slope, then what do you look at?
The y.
Y-intercept. Different y-intercepts, parallel lines. Parallel lines. Same y-intercept, same line. They're not parallel, but it's the same line. Okay? If they're same slope with same y-intercept, they're the same line. These are very different y-intercepts. So we can look at that and say, sure enough, all we're looking at is the slope to begin with. They are the same. Then you glance over and look at the y-intercepts. They're different. These are parallel lines. Right? And I guess we want to plot those too, don't we? Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. Okay. Now, that first one, where would we begin to plot that? Negative 4. And where do we find that? Down the y-axis 4 units. There we have the y-intercept there, and then where do we go from there?
Up 3, right 1.
Up 3, right 1 would be the first one. Up another 3, right 1 would be the next one, up another 3, right 1 would be the next one. Ooh, my line's not very straight. Up another 3 and right 1, something up there. Or you could have gone down 3 and left 1. I don't know where we left it, but it's somewhere down there. Okay. Pretty ugly line, but, you know, generally you got it. How about the other one?
6. Well, go over 6 to the right.
Really?
You start. That's where you start.
I'm sorry?
You start from 6.
Okay, I couldn't hear it. Say a little
Start
louder.
from 6.
I'm sorry?
You start from 6.
Okay, and where do you go?
Right.
Really? What do we call that, 6? It's positive for sure. Huh? The y-intercept. Y is the vertical axis. Up 6. Don't say yours, okay? Up 6. 1, 2, 3, 4, 5, 6. Right there. That's where you start. And then where do we go from there?
Down 3.
No.
Well,
Oh, I see. Okay. Down 3, left 1. If you're wanting to do that. 1, 2, 3, and left 1. About right there. I can't draw very well. Down another 1, 2, 3, and left 1. Another down 1, 2, 3, and left 1. Another down 1, 2, 3, and left 1. And you could have tried to go up 3, 1, 2, 3, and right 1. Okay. It's not very good. Okay. Now, what's that?
can you say it?
No, I said parallel.
Parallel.
Same slope, different y-intercept. Parallel. Perpendicular, the product has to be the two slopes have to be opposite signs and reciprocal to one another. Or the product has to be -1.
So you chart that.
Yeah, you start with the slope. Same slope, different y-intercept, parallel lines. If it was same slope, same y-intercept, same line, okay, because you can't have any difference. And those, even though ugly drawing and stuff like that, it does look like they never, ever, ever will cross, okay? But again, you can't tell by looking, okay? Because someone could draw as ugly as me, and you can't say, well, it looks like they may be getting a little closer down there than they're, yeah, you can't tell by looking. Look at this. This is the place to look. Look at the slopes. They have to be identically the same with different y-intercepts and their parallel lines. Does that make sense? All right. Can we move on to the C part? Any questions before I move on? Here's the C part. Okay? Determine whether each pair of lines is parallel, perpendicular, or neither. So where will we begin? A little louder. Isolate the y. Add x to both sides. And what does that give you? Y is equal to x minus 3. What's the slope? M is equal to 1. Okay? This one over here, what are we wanting to do? Subtract 5x from both sides. We're trying to isolate the y. Minus 5x. Okay? And that would give us minus 5y is equal to minus 5x minus 10. Divide everything on both sides by minus 5. Okay, and what does that give you here? Y is equal to x plus 2. Minus divided by minus is plus. Okay. So, what can you tell me? What's the slope of the second line? So, its slope is also 1, and they have different y-intercepts, so therefore parallel lines. Absolutely. You don't need to graph it to tell it that. You just make sure the slopes are the same with different y-intercepts, different lines, but parallel. Okay? Now, I bet you they are going to graph it, so let them set up, well, let's see. Let me erase the ink so you can see what they're writing. Okay, first thing they're going to do is find the slope of each line by first solving for each equation for y. So in the first one, we would write down the equation again. Y minus x is equal to -3. And what's that next step? Add x to both sides. You do that, and what do you get? Y is equal to x minus 3. There we have it. What does that tell us? Slope is 1. Perfect. Okay? Slope is 1. Next, write down the second equation, and then do what? A little louder. Get what? I can't hear it. Subtract what? 5x from both sides. Perfect. My hearing's so bad. Sorry. And that gives you -5y equal -5x minus 10. Divide everything by -5, and that gives us y is equal to x plus 2. What's the slope? 1. So there's a real good chance these are going to be parallel lines. What confirms it? Different y-intercepts. So they're not the same lines. They're different lines, different y-intercepts, but with same slope. So those are parallel. And this is how they graphed. And sure enough, this one, the first one was y-intercept of -3. Oh, it looked like they got it quite on the money here. And then you go, ooh, this is, oh, yeah, slope was +1. Up 1, right 1, up 1, right 1, up 1, right 1. See, they're off a little bit here. Sorry about that. Up 1, right 1. They're really off, okay? The graphics person didn't do a very good job. On the next one, it's supposed to be 2, 0. Is this the one we did? Okay. 0, 2, I'm sorry, 0, 2. Up 1, right 1, up 1, right 1. See, they're not quite on the money. Both of those should be tilted up a little bit. Or down 1, left 1. See, they missed that one pretty badly, down 1, left 1. So both of those lines need to be canted just a little bit. But, what's that? Well, that's it. No, I mean, we won't say that. Yeah, okay. Just didn't get his graphics very good. Well, okay. So that was example 6C. Oh, that's the last one there. In the book, though, we have D's. Okay, so let's first do the C from the book. 4x plus 3y is equal to 6. And 2x minus 5y is equal, no, 2x minus y is equal to 5. All right. What we're trying to do is determine whether the lines are parallel, perpendicular, or neither. So what do we do? Say again?
Subtract the slope.
Okay, subtract the 4x. Is that what you're saying? Yeah. Subtract 4x from both sides. And what does that give us? No, 3y minus 4x plus 6. And now what? Divide both sides by 3. Everything on both sides by 3. And that gives us y is equal to -4/3 x plus 2. All right, what do we do on the second equation? Okay, isolate the y by subtracting 2x from both sides. And what does that give us? -y is equal to -2x plus 5. And then what do we do? Divide or multiply both sides by -1, which basically is going to make that a plus, and the last one a minus. You're just changing the signs of everything on both sides of the equation. Okay, I was lazy. What's that? I still couldn't hear. Okay, That's a
No, he's asking on the
Where do
first
you,
one.
yeah.
Oh.
Where do you get the 4?
where they're getting the 4.
The 4x.
4x plus 3y is equal to 6.
You got a minus.
Is that what you mean?
Yeah, where do you get the
Well, the 4x, and then we subtract 4x from both sides. Like you told me. Huh?
There's no 4 there.
That's
This
a
is
4x.
the
Minus
one in the
4x.
book, not the one.
It's ugly writing. You're making fun of me. I can
No,
tell.
no.
Yeah. It hurts, but I can live with it. Okay. All right.
He thought you were doing the one that was already out there, not the one from the book.
Yeah.
He saw the other equation.
Yeah. I crossed through those. Okay. On this first one, what was your slope?
Negative 4/3.
M is equal to negative 4/3. And this one over here,
2.
M is equal to 2. What you reckon?
No.
What's that?
No.
Neither. Okay. Because number one, they're not the same slope, obviously. Now they are opposite signs, which means they could maybe be perpendicular, except these are not reciprocals of each other. What would this slope have had to be for that to be a reciprocal? What would this slope have to be for that to be the reciprocal? Positive 3/4. What would this slope have to be for that to be the reciprocal? Negative what?
2. Negative 1/2.
1/2. Reciprocal. Okay. Negative, opposite sign, reciprocal. 1/2.
Yeah, pretty sure negative 8/3.
What's that?
Negative 8/3. No.
Where would you get that?
If you multiply.
Oh, if you multiply those two. Yeah. And that's not negative 1. Okay, got it. Okay, do you need to see those graphs? Up to you. Yay or nay? Nay? Okay. All right. Now, in the book, there's also a D one. So these two would be a neither. And if you look in the book, these are neither parallel nor perpendicular. So let me delete all that. Are there any questions before I delete? Okay. Let's do the D part from the text. 5x minus y. I can't read. 5x minus y is equal to 1. And x minus 5y is equal to negative 10. Okay. And what we're trying to do is decide whether those two lines parallel, perpendicular, or neither. Okay, subtract 5x from both sides because we're trying to isolate the y. So minus 5x from both sides. And what would that give us? Okay, negative y is equal to negative 5x plus 1. Either multiply or divide both sides by negative 1, which would be simply changing the signs of everything on both sides. So that would give you 5x minus 1. What's the slope of that line? Okay, the m is equal to 5. Second one. Subtract x from both sides. And what does that give us? Negative 5y is equal to negative x minus 10. And then what? Divide everything on both sides. I've got to sneeze, sorry. By negative 5. And what does that give you? Y is equal to 1/5 x plus 2. Okay, what can you tell me there? Say again? Slope is 1/5. So what can you tell me about these two lines? Say again? Neither! Because they're both positive slopes. They can't, okay, and they're not the same slope, so they can't be parallel, and they're not opposite signs, so they can't possibly be perpendicular either. But they are reciprocals of each other, but to be perpendicular, they have to be negative reciprocals. What would this have to be for that to be the negative reciprocal? That's what it is. Negative 1/5. What would this have to be for that to be the negative reciprocal? Negative 5. Perfect. They have to be opposite signs and reciprocals. Okay? These were reciprocals, but not opposite signs. Not parallel, not perpendicular, big neithers by. Okay. Now, remember on every one of these that we do an example in class, there's examples on the margin. As soon as you can, do those either when you get home or have a little bit of time outside of class, get those done. Okay. Let's look at page 760, 11.3 exercises. It's a concept check here. Slope is used to measure the blank of a line. Yeah, it's used to measure the slope of the line. Or the pitch or the rise over run. Yeah, any of those things would work. Slope is the horizontal over vertical change. No.
What?
Slope is the blank change compared to the other blank. And the choices are horizontal, vertical, horizontal, vertical. Slope is the which change compared to the which other change while moving along a line from one point to another. Slope is always rise, so that's the vertical change per horizontal change. That's it. Okay, so the first of those blanks was vertical, second horizontal. Number 2 concept check. Slope is the blank of a vertical change in blank called the blank rise or run to the horizontal change in blank, which is called the rise or run. Okay. I'm trying to think what in the world that first line should be. Maybe magnitude of the vertical change in, just too many blanks here. I think it may be in Y values, okay, called the rise to the horizontal change in X values called the run. That's the best I can figure. Maybe we shouldn't even do these. I don't know. Look at the graph on the right. Do most of you have books? Some of you do not. Okay. All right. See if you can follow this one right here. This graph right here. Start at the point -1, -4. That goes left 1, down 4. That one right down there. Okay. And count vertically up to the horizontal line that goes through the other plotted point. So you count up 1, 2, 3, 4, 5, 6. Up to 2, that would be up 6. Okay. What is the vertical change? 6. Up 6. Okay. Goodness gracious, this book's heavy. Okay, from that new position right over here, -1, 2, then we go to the right, how many places? 1, 2, 3, 4. Okay, so your horizontal change was +4. So up 6 over +4, that would be 3 over 2. So what is the quotient of the numbers found in parts A and B? What do we call that number?
Slope.
Slope. Okay, and number D, if we were to start at point 3, 2, that upper point here, and end at the point -1, -4, would the answer be the same or different?
One more time.
Okay, if we started at this one and moved this way, would the slope be the same? Okay, well, let's think about it. What would we do to get down here? 1, go down, 1, 2, 3, 4, 5, 6. That's a -6 over a -1, 2, 3, 4. -6 over -4 is 3 over 2. Yes, you get the same answer. So it doesn't matter which one you start. Both of them are going to change signs exactly the same. Okay. Then do number 4. It's a concept check. There's 4 parts there. Match them up, I think, is what they're doing. Match the graph with each line. So do that for number 4. So you don't have books. All of you have them here today anyway. You'll need to use books to do that. Then do any of the problems 5 through 8. Do 9 and or 10. Do any of the problems 11 through 16. And do any of the problems 17 through 20. Then do 21 or 22 or both. I hate it when they give you things that are wrong and say what went wrong. But it's not bad to think through, but I just hate for them to keep doing anything wrong. Okay, then do any of the problems 23 through 50. Okay? No, I'm sorry, 23 through 36. And then do any of the problems 37 through 50. And then finally, do any of the problems 51 through 56. All right, any questions? Now, if any of you are biological science majors, there's a real good graph on page 763 that is very applicable. If you're a business major, figure B on that is a good one for business. All right, that wraps up that. Let's move to 11.4. The wrong key. Okay. All right, that's what I wanted to hit. Nope, still the wrong one. Okay, that's what I needed. Okay, we'll end that and go to 11.4. And by the way, folks, 11.4 is the last section in chapter 11. That means the test is coming up pretty soon. So I should have had ready for you today, but I thought we had more to do in 11.3. I'll have ready for you next time a quiz on chapter 11. Okay? And then as soon as all of you get the quiz in, then we can have the test on chapter 11. Okay? So let's move on to 11.4. Hopefully I'm in the right one now, right? So we'll go from current slide. Okay. We're doing graphs of linear equations, not inequalities, but these in two variables. Okay? Now, up till now, we have been either giving 2 points and finding the line or the slope through those 2 points, given the equation of a line, determining the slope of the line, determining parallel, perpendicular, that kind of stuff. This time, we're going to go through some of these forms that we've already been talking about, slope-intercept form for the equation of a line. So if we're given enough information, we're going to use that form. We're going to graph a line using its slope and some point on the line. Okay? Just a little bit different. Then we have the slope and a point that's not necessarily the y-intercept. To graph it, still the same way. Identify the point and then use the slope to go from there. We'll write an equation of a line given its slope and any point on the line. Okay? That's going to be a new kind of form which we call point-slope formula. Okay? Now, guess what? This is not a bunch of memorization. I'll show you an easy way to always be able to get that if you need it. Number 4, write an equation of a line given 2 points on the line. But guess what? If you know 2 points, what can you determine? What about the line?
The slope.
The slope of the line. And once you have the slope of the line, and 1 point, you got 2, you can write the equation of the line. So, that's pretty easy. Then, number 5, find the equation of a line that fits a data set. Okay? So we will figure that one out as well. Let's see, are there any? Yes? Is it time? Oh. All right, you got to go. We'll have a few more minutes. Okay. Listen up and you'll see how far we got. All right, so we'll use the slope-intercept form. Slope-intercept form of the equation of a line with the slope m and y-intercept 0b. We know what it is. What is it? That's what you know. Slope is m, y-intercept 0b. What's the equation of that line? Y is equal to mx plus b. That's it. We've been using that. Where m is the slope and b is the y-coordinate of the y-intercept. 0b. Y-intercept, x is always going to be 0. X-intercept, the y would be 0. We're not doing x-intercept. Y-intercept, 0 would be. Okay? That's my favorite form of a line. Tells you as much information as you could possibly get out of an equation for a line. I always fall back on that if I possibly can. Now, they skipped example 1, didn't they? Shame on them. So let's go back. We'll have to do example 1 here. Okay? Forget about 2 for now. We're going to do, let me get my pen activated. We're going to do example 1 first. Identify the slope and y-intercept of the line with each equation. Here's the A one. Y is equal to negative 4x plus 1. Okay? This is not what we're doing. Okay? It said identify the slope and the y-intercept. What's your slope? Negative 4. What's your y-intercept?
1. 0.
Aha, 0, 1. Always give any point on the line as an ordered pair. If it's a y-intercept, the x is going to be 0. If it's an x-intercept, the y is going to be 0. Any other point, it'll be xy. Okay, good deal. B, y is equal to x minus 8. What can you tell me about that one?
Slope is 1.
M is equal to 1, because if you don't see coefficient, understand that to be 1, and y-intercept?
Is 0, -8.
0, -8. Perfect. Okay. C, that means yes in Spanish. That's y is equal to 6x. What's your slope? 6. What's your y-intercept? 0, 0. For it to be a y-intercept, x has to be 0. And since you don't see a y-intercept here, that means it's 0 as well. So what's the x-intercept of that line? 0, 0 as well. It's the same point. So you can't graph that line by the intercept method because it's the same point. You have to pick another point and go with that. Okay? Number D. Woo, y is equal to x over 4 minus 3/4. Okay. You may choose to rewrite that. How can you rewrite x over 4? 1/4 x minus 3/4. And what does that tell you? Slope is 1/4. And the y-intercept? 0, -3/4. Not one I'd like to be plotting too frequently. Okay? Perfect. Okay, any questions on that? Okay. All right, let's see if we can get example 2 done. That's right here in front of us. Write an equation of a line with a slope of -4 and y-intercept of 0, 9. What does an equation always have in it? An equal sign. So I'm going to write down an equal sign. What goes on one side or the other of that equal sign? Y. Why not? Okay. What goes on the other side?
4x, or
-4x. There's the slope, mx plus 9. Perfect. There it is. If you know the slope, that's going to be the coefficient of the x. And if you know the y-intercept, the coordinate of the y-intercept has to be a 0. So the 9 is the y-intercept. Is the second. Is the y coordinates of that point. Okay? That's the y-intercept. Okay? Now, that was the one they gave here. Let's do the one that's in the book. Write an equation of a line with a slope of 2/3 and y-intercept of 0, -1. Okay, say again. Y is equal to 2/3 x minus 1. I wish I could make it harder, but I haven't figured out a way to do it, okay? It's pretty straightforward, all right? Everybody see it? Any questions? Okay. All right, we'll start next time with the objective 2, which will be graphing each line using the slope and y-intercept. So we will pick up there. We've already been doing it, so this will be pretty easy to follow. Let's see about homework here in this section. There won't be too many we can do. I think you can do number 1. Yeah, I know you can do number 1. I think you can do number 2. We've been doing them like that. Some of them may be a little more difficult, but give a shot to number 2. Okay? And I believe you can probably even do number 3. This matching, pretty nice. Okay, we'll leave the rest of those till later. Good deal. Also, I'll try to have ready for you the quiz for chapter 11. And we'll be moving on. And if any of you haven't finished or turned in the quizzes from chapter 10 or done the test for chapter 10, please do so. I think I'm preaching to the choir here. Y'all have been here, get it done, but if not, please get those done. Because I hate for you to be a chapter behind. Okay. A little louder. A little bit.
Paper for tutoring.
Oh, for tutoring. Oh, okay. Yeah. Okay. Now, these are all the tutoring opportunities, but these are the ones in the, what they call the Space Center. Mm-hmm. Now, are you on Birmingham and Bessemer or just Bessemer? Yes. Just Bessemer. Okay, and the Space Center, you know where it is? Okay, yeah. It's Monday, okay, yeah, Monday, 12 to 4, with Mr. Tariq Lake. I've had him in class before. He's available then. And Tuesday, from 10:30 to 2:30 with Mr. Etheridge Mean. He's a former adjunct instructor, so he can tutor anything. Okay. Now that's in the Space Center. Down the hall here at the Student Support Services, I think they have it set up 5 days a week, and maybe even in the evening too. So you can check with them. You know where that one is? Okay, yeah. You can check there too. Now, I think I may have said before, Miss Hollins is the person to contact. I found out last week she's no longer with us. So, Miss Harris. So to get to Miss Harris, you go all the way to the end of the hall, hang a left, and the last door on the right before you get to the restrooms. That's her office. Check with the secretary there or Miss Harris, and she can help get you lined up for that. Since you're a math student, before you get that far, you go down the hall past the tutoring lab, there's a classroom on the left, and then the very next office to the classroom is Miss Martin, Cicely Martin. She tutors in that lab, and she would be able to help you too. Okay? All right, good deal. Is this going a little too fast, or does it seem okay?
It's okay.
Okay. All right, but good to get the tutoring. Get a different perspective on it a little bit. All right.